A radiologist takes an average of a few minutes to review a chest X-ray. An AI model can flag signs of pneumonia in seconds, and in some studies, it does it as accurately as an experienced doctor. That's not a future prediction. That's already happening inside hospitals today. In this video, we're breaking down exactly how artificial intelligence is transforming every layer of healthcare, from the hospital systems working behind the scenes, to diagnosis, to real-time patient monitoring through wearables, to how new drugs are discovered, and even the rise of generative AI and LLMs in clinical settings. We'll also walk you through a real case study building a pneumonia detection model from imaging data, so you can see how this works, not just hear about it. And by the end, we'll talk about the part most explainers skip: the risks, the ethics, and the real limitations of AI in healthcare. Because understanding where AI shouldn't be blindly trusted is just as important as understanding where it excels. Before we get into hospitals and diagnosis, let's start with the technology powering all of it: generative AI and large language models. Welcome to our exploration of generative AI. Generative AI is a fascinating field that represents a significant leap forward in artificial intelligence. It refers to a class of AI models capable of creating new content, such as text, images, or music, based on the data they have been trained on. This is a departure from traditional AI, which primarily focuses on recognizing patterns or making predictions. The true power of generative AI lies in its ability to mimic human-like creativity, offering the potential to revolutionize various industries. Imagine a world where content creation is automated, creativity is enhanced, and new ways of interacting with technology are constantly emerging. In healthcare, for instance, generative AI can be a game changer. It can generate synthetic medical data for research, which is invaluable for training AI models without compromising patient privacy. Additionally, it can create personalized patient communication, making healthcare more accessible and tailored to individual needs. As we delve deeper into this lesson, I encourage you to think about how generative AI might impact your field, especially in healthcare. Consider the possibilities it holds for innovation and efficiency, and how it might transform the way we approach challenges in this critical sector. In this slide, we're going to delve into the core concepts of generative AI by addressing three pivotal questions: what, how, and why. Let's start with, what is generative AI? As we've previously discussed, generative AI is a type of artificial intelligence that has the capability to generate new data. This is not just any data, but data that is novel and can mimic the patterns and structures of the data it was trained on. Now moving on to, how does it work? Generative AI models, such as generative adversarial networks, or GANs, and variational autoencoders, or VAEs, are at the forefront of this technology. These models learn from existing datasets to create new, similar data. They employ sophisticated algorithms to discern and replicate the intricate patterns and structures within the data. Imagine a GAN as a creative duo, where one part generates data and the other evaluates it, refining the output until it closely resembles the original data. Finally, let's explore why generative AI is important. It opens up a world of possibilities for innovation and efficiency. In the healthcare sector, for instance, generative AI can be a game changer. It can generate realistic medical images that are invaluable for training medical professionals, or simulate patient data to test new treatments without risking real patient safety. As we continue, consider how these concepts might apply to your work and the transformative potential they hold for the healthcare industry. Generative AI is not just about creating data. It's about creating opportunities for advancement and improvement in various fields. Now, let's delve into the fascinating world of large language models, or LLMs. These models are a specialized branch of generative AI, primarily focused on understanding and generating human language. Imagine having a tool that can read, comprehend, and even generate text just like a human. That's what LLMs are designed to do. They are trained on enormous data sets of text, enabling them to perform a wide array of language-related tasks, such as translation, summarization, and engaging in conversations. The true power of LLMs lies in their ability to produce text that is remarkably human-like, making them invaluable for applications like chatbots, virtual assistants, and automated content creation. In the healthcare sector, LLMs can revolutionize the way we analyze patient records, assist in diagnosis by interpreting vast amounts of medical literature, or even provide patient support through conversational agents. As we explore LLMs further, think about how they could enhance communication and efficiency in your field. Whether it's streamlining administrative tasks or improving patient interactions, the potential applications are vast and transformative. Consider how these models might be integrated into your work to not only improve efficiency, but also to provide more personalized and effective healthcare solutions. In this slide, we're going to delve into the fascinating comparison between large language models, or LLMs, and traditional AI models, highlighting their key differences. Traditional AI models are typically designed for specific tasks. Imagine a tool crafted solely for image recognition or sentiment analysis. These models excel in their designated areas, but are limited to those specific functions. On the other hand, LLMs are like the Swiss Army knives of AI. They are incredibly versatile, capable of handling a multitude of language-related tasks with just one model. This versatility stems from their advanced architecture, which allows them to learn from a broader context, enabling them to generate text that is not only coherent, but also contextually relevant. Another significant difference is the scale. LLMs are typically much larger than traditional models, trained on extensive data sets. This vast training allows them to understand and generate more nuanced language, capturing subtleties that smaller models might miss. In the realm of healthcare, this means LLMs can offer more comprehensive support. They can interpret complex medical texts, engage in meaningful patient interactions, and provide insights that are both deep and wide-ranging. As we move forward, consider how these differences might influence the adoption of LLMs in your work, potentially transforming how tasks are approached and executed in your field. Now let's delve into some real-world applications of generative AI in the healthcare sector. Generative AI is revolutionizing healthcare in several impactful ways. One prominent application is the creation of synthetic medical data. This synthetic data is invaluable because it allows us to train other AI models without risking patient privacy. Imagine being able to develop robust AI systems without ever exposing sensitive patient information. Another exciting application is in the realm of drug discovery. Generative AI can simulate molecular structures, which helps researchers identify potential new drugs more efficiently. This capability accelerates the drug development process, potentially bringing life-saving medications to market faster. Furthermore, generative AI plays a crucial role in personalized medicine. By analyzing a patient's unique genetic makeup, it can generate tailored treatment plans, ensuring that each patient receives the most effective care possible. In radiology, generative AI enhances image quality and can even generate new images to aid in diagnosis. This means clearer, more accurate images for radiologists to work with, leading to better diagnostic outcomes. These examples highlight the transformative potential of generative AI in healthcare, offering innovative ways to improve patient outcomes and streamline processes. As we discuss these applications, consider how they might be integrated into your practice or research, and think about the possibilities they open up for the future of healthcare. As we wrap up our exploration of generative AI, it's crucial to take a balanced view of its strengths and limitations. One of the standout strengths of generative AI is its remarkable ability to generate new and diverse data. This capability is a game changer for innovation and creativity, allowing us to explore possibilities that were previously unimaginable. Imagine being able to create synthetic medical data that can train other AI models without risking patient privacy. Another significant strength is scalability. Generative AI models can be trained on vast datasets, enabling them to perform complex tasks with impressive efficiency. This scalability is particularly beneficial in fields like healthcare, where large volumes of data are the norm. However, it's important to acknowledge the limitations. Generative AI models can be resource-intensive, demanding substantial computational power and data. This can be a barrier for smaller organizations or those with limited resources. Additionally, if these models are trained on biased data, they may produce biased or inaccurate outputs. In healthcare, this could lead to serious consequences, such as incorrect diagnoses or treatment recommendations. Ethical concerns also come into play, particularly around data privacy and the potential misuse of generated content. For instance, if synthetic data is not handled properly, it could inadvertently reveal sensitive information. As we conclude this lesson, I encourage you to reflect on how you can leverage the strengths of generative AI while being mindful of its limitations. Consider how you can integrate these insights into your work, ensuring that you harness the power of generative AI responsibly and effectively. Welcome to our discussion on AI in managing electronic health records, or EHRs. Electronic health records are digital versions of patients' paper charts and are crucial for modern healthcare systems. They contain comprehensive patient data, including medical history, diagnoses, medications, treatment plans, immunization dates, allergies, radiology images, and laboratory test results. The integration of AI into EHR systems is transforming how healthcare providers manage and utilize this data. AI can automate data entry, reduce errors, and provide predictive analytics to improve patient outcomes. For instance, AI algorithms can analyze EHR data to identify patients at risk of developing certain conditions, allowing for early intervention. This not only enhances patient care, but also optimizes the workflow for healthcare providers. As we delve deeper, consider how AI's ability to process and analyze large volumes of data can revolutionize the way we manage health records. Building on our previous discussion about electronic health records, let's delve into the transformative benefits of incorporating AI into these systems. AI offers a multitude of advantages that significantly enhance the functionality and efficiency of electronic health records. One of the primary benefits is the improvement in the accuracy and efficiency of data entry. By automating routine tasks, AI reduces the administrative burden on healthcare professionals, allowing them to dedicate more time to patient care. Imagine the relief for clinicians who can now focus on what truly matters, caring for their patients, while AI handles the repetitive data entry tasks. Moreover, AI enhances decision-making by providing real-time insights and predictive analytics. For instance, AI can analyze patient data to predict potential health risks, enabling proactive care management. This means that healthcare providers can intervene earlier, potentially preventing more serious health issues down the line. Another significant advantage is the facilitation of interoperability between different electronic health record systems. AI ensures seamless data exchange, which is crucial for maintaining the continuity of care. This interoperability means that no matter where a patient receives care, their health records are accessible and up to date, improving the overall quality of care. These benefits not only lead to better patient outcomes, but also contribute to cost savings for healthcare organizations. By reducing errors, improving efficiency, and enabling proactive care, AI helps healthcare systems operate more effectively and economically. As we continue, consider how these advantages could be applied in your own healthcare setting to enhance both patient care and operational efficiency. Now let's delve into how AI can optimize healthcare workflows. Imagine a bustling hospital environment where every second counts. AI technologies can significantly streamline various processes within healthcare systems, ranging from scheduling appointments to managing patient flow. By analyzing data patterns, AI can predict peak times and allocate resources accordingly, which helps in reducing wait times and improving patient satisfaction. For instance, AI can assist in triaging patients by analyzing symptoms and medical history, ensuring that those in need of urgent care are prioritized. This not only speeds up the process, but also ensures that critical cases receive the attention they need promptly. Moreover, AI can automate administrative tasks such as billing and coding. This automation reduces errors and frees up staff to focus more on patient care, rather than getting bogged down by paperwork. These optimizations lead to more efficient healthcare delivery and better resource management. As we move forward, consider how AI-driven workflow improvements can enhance the overall patient experience in your healthcare facility. Think about the potential impact on patient satisfaction and operational efficiency when AI is integrated into your systems. The possibilities are vast and can lead to a transformative change in how healthcare is delivered. In this case study, we delve into a fascinating example of how AI has been harnessed to enhance workflow efficiency in a healthcare setting. Imagine a bustling hospital that decided to implement an AI-driven system to streamline patient admissions and discharges. The AI system, by analyzing historical data, could predict patient discharge times with remarkable accuracy. This capability allowed the hospital to optimize bed management, significantly reducing patient wait times for admission. But that's not all. The AI system also automated the scheduling of follow-up appointments and coordinated seamlessly with outpatient services. This ensured a smooth transition for patients leaving the hospital, enhancing their overall experience. As a result, the hospital witnessed a notable reduction in bottlenecks and a marked improvement in patient throughput. This case study vividly illustrates the potential of AI to not only enhance operational efficiency, but also improve patient care. It prompts us to reflect on how similar AI applications could be implemented in your own healthcare environment, potentially transforming the way you manage workflows and patient interactions. Consider the possibilities and think about the impact such innovations could have on your healthcare facility. Natural language processing, or NLP, is a fascinating branch of artificial intelligence that focuses on the interaction between computers and humans through natural language. In the realm of healthcare, NLP holds the potential to revolutionize how we handle unstructured data, such as clinical notes, patient narratives, and research articles. Imagine a scenario where NLP algorithms sift through physician notes to uncover trends and patterns that might not be immediately obvious. This capability can significantly aid in diagnosis and treatment planning, providing healthcare professionals with insights that enhance patient care. Moreover, NLP can be a powerful tool in extracting relevant information from the vast sea of medical literature, thereby supporting evidence-based practice. By doing so, it ensures that healthcare providers are equipped with the most current and relevant information to make informed decisions. Another exciting application of NLP is in enhancing patient engagement. Through chatbots and virtual assistants powered by NLP, patients can receive personalized health information and support, making healthcare more accessible and interactive. As we delve into the applications of NLP, consider how this technology can transform the way healthcare professionals access and utilize information, ultimately leading to improved patient outcomes and more efficient healthcare delivery. In our previous discussion, we explored the transformative potential of natural language processing, or NLP, in healthcare. Now, let's delve into the challenges that come with implementing NLP in this field. One of the primary hurdles is the complexity and variability of medical language. Medical professionals often use jargon, abbreviations, and context-specific terms that can be difficult for NLP algorithms to interpret accurately. Imagine trying to decode a language that changes its rules depending on the context. This is what NLP faces in healthcare. Another significant challenge is the nature of healthcare data itself. It's often unstructured and scattered across various systems, making integration a daunting task. Think of it like trying to piece together a puzzle where the pieces are spread across different rooms. Privacy and security concerns also loom large when dealing with sensitive patient information. The stakes are high, as any breach could have serious implications. Furthermore, developing effective NLP models requires large annotated datasets. However, obtaining such datasets in healthcare is not straightforward due to privacy regulations and the need for precise annotations. Addressing these challenges is not a solo endeavor. It requires a collaborative effort among healthcare professionals, data scientists, and regulatory bodies. Together, they can ensure that NLP applications are not only accurate and reliable, but also secure. As we discuss these challenges, I encourage you to think about potential solutions and strategies that you could apply in your own practice. Ensuring patient data privacy is a critical concern when implementing AI in healthcare. In this digital age, where data breaches are increasingly common, protecting sensitive patient information is paramount. AI systems must comply with regulations such as the Health Insurance Portability and Accountability Act, or HIPAA, which sets stringent standards for safeguarding patient data. To effectively protect data privacy, AI systems can employ several techniques. One such technique is data anonymization, which involves removing personally identifiable information from datasets. This ensures that even if data is accessed, it cannot be traced back to an individual. Another vital technique is encryption. Encryption protects data during transmission and storage by converting it into a code that can only be deciphered by authorized parties. This means that even if data is intercepted, it remains unreadable and secure. Access controls are also crucial. They ensure that only authorized personnel can access sensitive information, thereby minimizing the risk of unauthorized access. Additionally, AI can be leveraged to monitor and detect unauthorized access or data breaches. By analyzing patterns and anomalies, AI systems can provide an additional layer of security, alerting administrators to potential threats in real time. As we explore these privacy measures, consider how they can be applied to protect patient data in your healthcare organization. Think about the specific challenges your organization faces and how these AI-driven solutions can be tailored to meet those needs. Building on our discussion about patient data privacy, let's now explore how AI solutions can enhance data security in healthcare. AI is pivotal in identifying and mitigating security threats by analyzing patterns and detecting anomalies in real time. Imagine AI algorithms as vigilant security guards, constantly monitoring network traffic to spot suspicious activities, such as unauthorized access attempts or data exfiltration. Machine learning models can be trained to recognize and respond to emerging threats, offering proactive security measures that adapt to new challenges. Additionally, AI can automate the process of patch management, ensuring that systems are consistently updated with the latest security patches. This automation not only saves time, but also reduces the risk of human error, which can be a significant vulnerability in security protocols. These AI-driven security solutions are essential for protecting sensitive patient data and maintaining the integrity of healthcare systems. As we conclude, consider how integrating AI into your organization's security strategy could enhance data protection and provide peace of mind in safeguarding patient information. Welcome to our lesson on AI in medical diagnosis. In this session, we'll explore how artificial intelligence is transforming the field of medical diagnosis. AI in medical diagnosis refers to the use of algorithms and software to emulate human cognition in the analysis, interpretation, and comprehension of complex medical data. This technology is crucial because it can process vast amounts of data quickly and accurately, which is essential in diagnosing diseases. Imagine a world where a computer can analyze your medical images and provide a diagnosis faster than a human doctor. This is not science fiction. It's happening now. AI is being used to detect diseases like cancer, heart disease, and neurological disorders with remarkable accuracy. As we delve deeper into this topic, think about how AI could change the way we approach healthcare and the potential benefits and challenges it brings. Building on our understanding of AI in medical diagnosis, let's delve into its importance. AI is truly revolutionizing the healthcare industry by significantly enhancing diagnostic accuracy and efficiency. One of the standout benefits of AI is its remarkable ability to analyze large data sets swiftly. This capability is crucial because it helps in identifying patterns and anomalies that might be easily overlooked by the human eye. This is particularly vital in the realm of early disease detection, where a timely diagnosis can dramatically improve patient outcomes. For instance, AI algorithms are capable of analyzing medical images to detect early signs of cancer, which allows for earlier intervention and potentially life-saving treatments. Moreover, AI plays a pivotal role in reducing the workload of healthcare professionals. By automating routine tasks, AI enables doctors and nurses to focus their expertise on more complex cases, thereby enhancing the overall quality of patient care. As we continue to explore this topic, consider how AI can complement human expertise in healthcare. Think about the potential it holds to not only improve patient care, but also to transform the way healthcare is delivered. The integration of AI in medical diagnosis is not just about replacing human effort, but about augmenting it, creating a synergy that could lead to unprecedented advancements in patient care. Now, let's delve into the fascinating role of machine learning in diagnostic imaging. Machine learning, a powerful subset of artificial intelligence, involves training algorithms to recognize patterns within vast amounts of data. In the realm of diagnostic imaging, these algorithms are trained on thousands, sometimes millions, of medical images to identify features that are associated with specific diseases. For instance, in the field of radiology, machine learning can be employed to detect tumors in X-rays or MRIs with remarkable accuracy. Imagine a scenario where these algorithms highlight areas of concern, effectively providing radiologists with a second opinion. This not only reduces the chances of misdiagnosis, but also enhances the confidence in the diagnostic process. The use of machine learning in diagnostic imaging doesn't just stop at improving accuracy. It also significantly speeds up the diagnostic process, allowing for quicker treatment decisions, which is crucial in time-sensitive medical situations. As we explore this topic further, consider the transformative potential of machine learning in other areas of healthcare. How might it revolutionize the way we approach diagnosis and treatment across various medical fields? Keep these thoughts in mind as we continue our journey through the world of AI in healthcare. All right, let's now dive into a hands-on exercise to put today's ideas into practice. We'll be working with a simple machine learning model using Python to classify medical images. First, we import the necessary libraries. We're using TensorFlow's Keras API, which provides a high-level interface for building and training deep learning models. Specifically, we import the VGG16 model, which is a pre-trained model available in Keras, along with some utility functions for image processing and model building. Next, we load the VGG16 model pre-trained on ImageNet, excluding the top layers. This means we're using the model's feature extraction capabilities without its final classification layers. This is useful because we want to add our own custom layers for our specific task of tumor detection. We then freeze the base model. This means we set all the layers in the VGG16 model to be non-trainable. By doing this, we ensure that the pre-trained weights are not updated during training, which helps in retaining the learned features from ImageNet. After that, we add custom layers on top of the base model. We flatten the output of the base model, add a dense layer with 256 units and a ReLU activation function, and finally add an output layer with a single unit and a sigmoid activation function. This setup is typical for binary classification tasks, where we want to predict one of two possible outcomes. We then create the final model by specifying the inputs and outputs. This model combines the feature extraction capabilities of VGG16 with our custom classification layers. Next, we compile the model. We use the Atom Optimizer, which is a popular choice for training deep learning models, and specify binary cross-entropy as the loss function. Since we're dealing with a binary classification problem, we also track accuracy as a metric to evaluate the model's performance. To simulate training data, we use the Image Data Generator class to create a data generator that will load images from a directory. In a real-world scenario, you would load actual medical images, but for this example, we're just setting up the process. We then simulate the training process, although we won't actually run this line. The model would typically be trained using the fit method, which takes the data generator and the number of epochs as arguments. For prediction, we simulate the process by creating a random image error. Why? In practice, you would load an actual image for prediction. We then use the model to predict the class of the random image. The prediction will be a value between 0 and 1, where 0 indicates no tumor and 1 indicates the presence of a tumor. Finally, we output the prediction. This line will print the prediction result, allowing us to see whether the model predicts a tumor or not. In summary, we've walked through a simplified example of using a pre-trained model to classify medical images. This exercise highlights the potential of machine learning in diagnostic imaging. As we discussed earlier, remember, in a real-world application, you would need a properly labeled dataset of medical images for training and validation. Feel free to experiment with the code, perhaps by trying different pre-trained models or adjusting the custom layers. This hands-on practice reinforces the connection between the abstract concepts of machine learning and their practical applications in healthcare. In this slide, we're delving into the fascinating real-world applications of AI in diagnostic imaging. Let's start with mammography, a critical tool in detecting breast cancer. AI algorithms have been developed to analyze mammograms, pinpointing suspicious areas that might indicate cancer. What's remarkable is that these AI systems often achieve greater accuracy than human radiologists, offering a powerful second opinion. Another significant application is in the detection of lung diseases through chest X-rays. AI can swiftly analyze these images to identify signs of pneumonia, tuberculosis, or even lung cancer. This rapid analysis is crucial, as it allows healthcare professionals to make more accurate and timely diagnoses, ultimately improving patient outcomes. As we discuss these examples, consider the profound impact AI has on patient care. It not only enhances diagnostic accuracy, but also speeds up the process, enabling quicker treatment decisions. Imagine the potential for AI to be integrated into other diagnostic processes, revolutionizing the way we approach healthcare. These applications are just the beginning, showcasing how AI can assist healthcare professionals in delivering better care. As we move forward, think about the broader implications of AI in healthcare and how it might transform other areas of diagnosis. Now, let's delve into the fascinating world of AI applications in pathology and histology. Pathology, as you might know, involves the meticulous examination of tissues to diagnose diseases, while histology focuses on studying the microscopic structure of these tissues. AI is revolutionizing these fields by analyzing histological images to identify abnormalities and diagnose diseases, such as cancer, with remarkable precision. Imagine AI algorithms trained to recognize intricate patterns in tissue samples that indicate the presence of cancerous cells. This capability not only aids pathologists in making more accurate diagnoses, but also significantly reduces the time required for analysis. Furthermore, AI can quantify the extent of a disease, providing invaluable information for treatment planning. As we explore these applications, consider how AI enhances the capabilities of pathologists, improving diagnostic accuracy and ultimately patient outcomes. In this case study, we're diving into the fascinating world of AI in histological analysis. Imagine a scenario where AI is employed to analyze biopsy samples for cancer diagnosis. Traditionally, pathologists have the meticulous task of examining these samples under a microscope. This process, while thorough, can be quite time-consuming and is not immune to human error. Enter AI. With the power of digital imaging and sophisticated algorithms, AI can analyze these samples with remarkable precision. These algorithms are trained to detect cancerous cells, and in one notable study, AI achieved an accuracy rate comparable to that of seasoned pathologists. This advancement not only accelerates the diagnostic process, but also offers a valuable second opinion, significantly reducing the chances of misdiagnosis. As we delve into this case study, consider the profound implications of AI in histology. How can it enhance patient care? By providing faster, more accurate diagnoses, AI has the potential to revolutionize the way we approach cancer diagnosis and treatment. It's an exciting time in the field of medical diagnostics, and AI is at the forefront, paving the way for improved patient outcomes. Now, let's delve into the fascinating role of natural language processing, or NLP, in the realm of medical diagnostics. NLP is a specialized branch of artificial intelligence that focuses on the seamless interaction between computers and humans through natural language. In the healthcare sector, NLP has the potential to revolutionize the way we handle unstructured data, such as clinical notes, by extracting valuable insights that can aid in diagnosis. Imagine a scenario where NLP algorithms sift through electronic health records to pinpoint symptoms, compile medical histories, and outline treatment plans. This process provides healthcare professionals with a holistic view of a patient's health, enabling them to make more informed and accurate diagnostic decisions. As we explore the capabilities of NLP, consider the transformative potential of this technology in reshaping how we process and utilize medical data. By leveraging NLP, we can enhance the efficiency and accuracy of medical diagnostics, ultimately improving patient outcomes and care. Think about the possibilities: faster diagnosis, reduced human error, and a more comprehensive understanding of patient health. NLP is not just a tool, it's a game changer in the field of medical diagnostics. In this slide, we're diving into the challenges and opportunities that natural language processing, or NLP, presents in the realm of medical diagnostics. One of the primary challenges we face is the inherent complexity of medical language. This complexity is not just about the technical jargon, but also the variations that exist across different medical specialties and regions. Imagine trying to understand a conversation where the dialect changes every few sentences. That's what NLP systems often encounter in medical texts. Another significant hurdle is the nature of medical data itself. Much of it is unstructured, meaning it doesn't follow a consistent format, and it can be riddled with errors or inconsistencies. Think of it like trying to piece together a puzzle where some pieces are missing or don't quite fit. Despite these challenges, NLP holds tremendous promise for enhancing diagnostics. By extracting and analyzing data from electronic health records, NLP can uncover patterns and trends that might not be immediately visible to the human eye. This capability can lead to more accurate diagnoses and the development of personalized treatment plans tailored to individual patients. As we explore these challenges and opportunities, consider how NLP can be seamlessly integrated into existing healthcare systems. The goal is to enhance diagnostic capabilities, making them more efficient and effective. Think about the potential impact on patient care and how it could revolutionize the way healthcare professionals approach diagnosis. Now, let's delve into the fascinating world of AI techniques for predictive diagnostics. Predictive diagnostics is a groundbreaking approach that leverages artificial intelligence to foresee the likelihood of a disease developing in a patient. This is achieved by analyzing their medical history and other relevant data. Machine learning algorithms play a pivotal role here. They can sift through vast data sets to pinpoint risk factors and predict potential disease outcomes. For instance, consider the risk of heart disease. AI can analyze a combination of data points such as age, lifestyle choices, and genetic predispositions to predict this risk. This predictive capability allows healthcare providers to intervene early and craft personalized treatment plans, which can significantly enhance patient outcomes. As we explore these techniques, I encourage you to think about the transformative potential of predictive diagnostics in preventive healthcare. However, it's also crucial to consider the challenges that may arise in implementing these technologies, such as data privacy concerns and the need for robust data integration systems. All right, let's now dive into a hands-on exercise to put today's ideas into practice. We're going to build a simple predictive model for heart disease risk using machine learning. We'll start by importing the necessary libraries. Here, we use NumPy and Pandas for data manipulation, and scikit-learn for building our machine learning model. Next, we create a synthetic dataset. Imagine this dataset as a collection of patient data, where each patient has attributes like age, lifestyle, and genetic predisposition. These attributes will help us predict the risk of heart disease. We then convert this data into a data frame using Pandas, which makes it easier to work with. After that, we split our data into features and target variables. The features are the attributes we mentioned earlier, and the target is the heart disease risk. Now we need to split our data into training and testing sets. This is crucial because we want to train our model on one part of the data and test its performance on another. We initialize a random forest classifier, which is a type of machine learning algorithm that works well for classification tasks. We then train our model using the training data. This is where the model learns the patterns in the data. Once the model is trained, we make predictions on the test set to see how well our model performs. We evaluate the model's performance by calculating its accuracy and generating a classification report. The accuracy tells us the percentage of correct predictions, while the classification report provides detailed performance metrics. Remember, this is a simple model, and there are many ways to improve it. For instance, you could use more sophisticated feature engineering, implement cross-validation, or try more advanced algorithms like gradient boosting or neural networks. Also, consider adding error handling to manage potential issues with data processing or model training. Finally, always ensure data privacy by anonymizing patient data and following data protection regulations. By completing this exercise, you've seen how machine learning can be applied to predictive diagnostics, specifically for predicting heart disease risk. This hands-on experience reinforces the transformative potential of AI in healthcare. I encourage you to experiment with the code, try different algorithms, and see how they affect the model's performance. As we wrap up our exploration of AI in predictive diagnostics, let's turn our attention to the exciting future trends in this field. With the rapid advancement of AI technology, we are on the brink of developing more sophisticated predictive models. These models will be capable of analyzing a broader spectrum of data sources, including genetic information and real-time health data from wearable devices. Imagine a future where your smartwatch not only tracks your steps, but also provides insights into your health risks based on your genetic makeup and daily activities. Such advancements will lead to more accurate predictions and enable healthcare providers to create personalized healthcare plans tailored specifically to individual patients. This means that treatments and interventions can be more precisely targeted, improving patient outcomes and potentially reducing healthcare costs. Furthermore, the integration of AI with other cutting-edge technologies, such as the Internet of Things, will significantly enhance the capabilities of predictive diagnostics. For instance, smart home devices could monitor a patient's health metrics and communicate with healthcare providers in real time, allowing for timely interventions. As we consider these future trends, it's crucial to reflect on the potential impact on healthcare. While the benefits are immense, we must also be mindful of the ethical considerations that may arise as AI becomes more deeply integrated into diagnostic processes. Issues such as data privacy, consent, and the potential for bias in AI algorithms need to be addressed to ensure that these technologies are used responsibly and equitably. The future of predictive diagnostics is indeed promising, and as we continue to innovate, we must strive to balance technological advancement with ethical responsibility. Welcome to our first slide on understanding pneumonia. Pneumonia is an infection that inflames the air sacs in one or both lungs, which can fill with fluid or pus, causing symptoms like a cough with phlegm or pus, fever, chills, and difficulty breathing. It's crucial to understand pneumonia because it is a leading cause of morbidity and mortality worldwide, especially among children under 5 and the elderly. By understanding its definition and importance, we can appreciate the need for effective detection and treatment methods. Now, let's think about why early detection is vital. How might early detection impact patient outcomes? Early detection can significantly improve patient outcomes by allowing for timely intervention, reducing the severity of the disease, and preventing complications. It can also help in reducing the spread of infection, especially in vulnerable populations. This understanding sets the stage for exploring advanced detection methods such as AI, which can revolutionize how we approach pneumonia diagnosis and treatment. Pneumonia is a formidable challenge in global health, impacting millions of lives each year. It is a leading cause of hospitalizations and deaths, particularly in low and middle-income countries, where healthcare access is often limited. This disparity highlights the urgent need for improved detection and treatment strategies. The economic burden of pneumonia is also significant, with costs stemming from medical treatments and lost productivity due to illness. By understanding these impacts, we can better appreciate the importance of advancing our detection and treatment methods. Now, consider how technology might alleviate some of these burdens. Could innovations in technology, such as artificial intelligence, play a role in reducing the incidence and severity of pneumonia? Artificial intelligence is playing a transformative role in revolutionizing pneumonia detection. Imagine a world where machines can analyze medical images with such precision that they often surpass human capabilities. This is not just a futuristic dream. It's happening now thanks to AI technologies, particularly machine learning and deep learning. These technologies can scrutinize medical images with remarkable accuracy, enabling faster and more precise diagnoses. This advancement is crucial because timely diagnosis can significantly impact treatment outcomes, potentially saving lives. Moreover, AI doesn't just stop at diagnosis. It can also predict outbreaks and help manage healthcare resources more effectively. For instance, by analyzing patterns in data, AI can forecast where and when pneumonia outbreaks might occur, allowing healthcare providers to allocate resources efficiently and prepare in advance. Now, let's consider how AI compares to traditional methods. Traditional methods rely heavily on human expertise, which, while invaluable, can be limited by human error and the sheer volume of data. AI, on the other hand, can process vast amounts of data quickly and consistently, reducing the likelihood of oversight. This efficiency and accuracy make AI a powerful tool in the fight against pneumonia. So, how do you think AI stacks up against traditional methods in terms of efficiency and accuracy? In this slide, we delve into the significant benefits of using AI for the early detection of pneumonia. AI's ability to process vast amounts of data swiftly is a game changer. It can identify subtle patterns in medical images that might be overlooked by even the most trained human eyes. This leads to earlier detection, which is crucial for effective treatment and significantly improves patient outcomes. By automating the initial analysis, AI reduces the workload on healthcare professionals, allowing them to dedicate more time to direct patient care. This is especially beneficial in busy healthcare settings where time is of the essence. Moreover, AI systems can be deployed in remote and underserved areas, providing access to advanced diagnostic tools where healthcare resources are limited. This democratization of healthcare technology ensures that even those in isolated regions can benefit from early detection and treatment. However, implementing AI in healthcare is not without its challenges. What potential obstacles do you think might arise when integrating AI into healthcare settings? Consider aspects like data privacy, the need for robust infrastructure, and the training required for healthcare professionals to effectively use these technologies. These are important considerations as we move forward in leveraging AI to enhance healthcare delivery. In the journey of using AI for pneumonia detection, data collection stands as a cornerstone. Imagine it as gathering the essential ingredients for a recipe. Here, our ingredients are chest X-rays, CT scans, and patient medical histories. These diverse data sources form the raw material that feeds into our AI models, enabling them to learn and make predictions. But why is diversity in data so crucial? Well, just like a balanced diet is essential for good health, a diverse dataset ensures that our AI models are well-rounded and capable of making accurate predictions across different patient demographics. This helps in minimizing biases that could skew the results. Now, let's not forget about data privacy and security. In healthcare, these are not just buzzwords, they are critical components. Protecting patient information is paramount, and any breach could have serious implications. So, how does data quality impact AI model performance? Think of it like building a house. If the foundation is weak, the entire structure is at risk. Similarly, poor quality data can lead to inaccurate AI predictions, which in healthcare could mean the difference between life and death. As we move forward, consider how each piece of data contributes to the bigger picture of AI-driven healthcare solutions. Pre-processing is a crucial step in preparing pneumonia data for AI analysis. It involves several techniques such as normalization, noise reduction, and data augmentation, each playing a vital role in enhancing the data's quality. Let's break these down. Normalization adjusts the data to a common scale without distorting differences in the ranges of values. This is particularly important when dealing with medical images like X-rays, where pixel intensity can vary significantly. Noise reduction helps in removing irrelevant or misleading information from the data, ensuring that the AI model focuses on the most pertinent features. Imagine trying to listen to a conversation in a noisy room. Noise reduction is like filtering out that background chatter. Data augmentation, on the other hand, is like adding more spices to a dish to enhance its flavor. It artificially increases the diversity of the training set by creating modified versions of the data, such as rotating or flipping images. This process improves the model's robustness by exposing it to a wider variety of scenarios. Now, why is pre-processing necessary before feeding data into AI models? Well, it ensures that the data is clean, consistent, and comprehensive, which is essential for training effective AI models. Without pre-processing, the model might learn from flawed data, leading to inaccurate predictions. So, think of pre-processing as setting the stage for a successful performance by your AI model. In this slide, we will explore the various machine learning models that are commonly employed for pneumonia detection. These models include decision trees, support vector machines, and neural networks. Each of these models has its unique strengths and is selected based on the specific requirements of the task at hand. For instance, decision trees are known for their simplicity and interpretability, making them a good choice for initial model building and understanding the data. Support vector machines, on the other hand, are powerful for classification tasks, especially when the data is not linearly separable. Neural networks, particularly, are often favored for image analysis tasks due to their ability to capture and learn complex patterns and features from the data. This makes them particularly effective in analyzing medical images like chest X-rays, which are crucial for pneumonia detection. Now, consider this. How do you think the choice of model affects the outcome of pneumonia detection? The choice of model can significantly impact the accuracy, speed, and reliability of the detection process. For example, while neural networks might offer high accuracy, they also require more computational resources and time for training compared to simpler models like decision trees. Therefore, the decision on which model to use often involves a trade-off between accuracy, interpretability, and computational efficiency. Understanding these trade-offs is essential for selecting the most appropriate model for a given scenario. In this case study, we explore the implementation of machine learning models for pneumonia detection, focusing on a real-world example from a hospital setting. Here, a convolutional neural network, or CNN, was employed to analyze chest X-rays. This model achieved remarkable accuracy, which significantly reduced the time required for diagnosis. This advancement not only improved patient outcomes by enabling quicker treatment, but also optimized hospital resources, allowing medical staff to focus on more critical tasks. Now, what were the key factors that contributed to the success of this implementation? First, the choice of a CNN was crucial. CNNs are particularly well suited for image analysis due to their ability to recognize complex patterns and features in visual data. Second, the availability of a large and diverse dataset of chest X-rays allowed the model to learn effectively and generalize well to new data. Third, the integration of this technology into the hospital's workflow ensured that the model's predictions could be quickly acted upon, enhancing the overall efficiency of the diagnostic process. These factors combined to create a robust system that not only met but exceeded the hospital's expectations for pneumonia detection. Deep learning is a fascinating subset of machine learning, and it plays a crucial role in the field of pneumonia detection. Unlike traditional machine learning, deep learning involves neural networks with multiple layers, often referred to as deep neural networks. These layers enable the model to learn complex patterns and representations from vast amounts of data. One of the most powerful types of deep learning models used in medical imaging is the convolutional neural network, or CNN. CNNs are particularly adept at analyzing visual data, such as chest X-rays, because they can automatically extract and learn features from the images. This capability significantly reduces the need for manual feature extraction, which is often time-consuming and requires expert knowledge. Now, you might wonder how deep learning compares to traditional machine learning in terms of capabilities. Well, deep learning models generally excel in handling large and complex datasets, making them ideal for tasks like image recognition and classification. They can capture intricate patterns that might be missed by traditional machine learning models, which often rely on handcrafted features. So, in the context of pneumonia detection, deep learning not only enhances the accuracy of diagnosis, but also speeds up the process, ultimately leading to better patient outcomes. This is why deep learning is becoming an indispensable tool in the healthcare industry, particularly in the analysis of medical images. In this case study, we're diving into the fascinating world of deep learning and its application in detecting pneumonia. Imagine a research team that has developed a cutting-edge deep learning model capable of analyzing chest X-rays with remarkable precision. This model was trained on an extensive data set, which enabled it to generalize effectively to new, unseen data. The significance of this application lies in its potential to significantly enhance diagnostic accuracy and speed, which is crucial in medical settings. By leveraging deep learning, healthcare professionals can make quicker and more accurate diagnoses, potentially saving lives. However, developing such a model is not without its challenges. The team likely faced hurdles such as ensuring the quality and diversity of the training data, optimizing the model's architecture, and addressing any biases that might arise from the data. These challenges are critical to consider because they directly impact the model's performance and reliability. So, what do you think were some of the specific obstacles the team encountered during the development of this model? Evaluating pneumonia detection models requires a careful examination of specific metrics to ensure their effectiveness. These metrics include accuracy, precision, recall, and the F1 score. Each of these plays a crucial role in providing insights into the model's performance. Accuracy measures the overall correctness of the model by comparing the number of correct predictions to the total number of predictions. However, relying solely on accuracy can be misleading, especially in cases where the data is imbalanced. For instance, if a data set has 95% healthy cases and only 5% pneumonia cases, a model that predicts all cases as healthy would still have a high accuracy of 95%, but it would be ineffective in detecting pneumonia. This is where precision and recall come into play. Precision tells us how many of the predicted pneumonia cases were actually correct, while recall indicates how many of the actual pneumonia cases were successfully identified by the model. Balancing precision and recall is essential to avoid biases in predictions. The F1 score is a harmonic mean of precision and recall, providing a single metric that balances both. It is particularly useful when the class distribution is uneven, as it gives a more comprehensive view of the model's performance. By understanding and balancing these metrics, we can assess the reliability of AI models in detecting pneumonia. This helps in identifying areas for improvement and ensuring that the model is both effective and fair. How do you think these metrics help in assessing the reliability of AI models? All right, let's now dive into a hands-on exercise to put today's ideas into practice. In this session, we will evaluate the performance of a pneumonia detection model. Our primary goal is to understand how different metrics reflect the model's capabilities. We'll be using a sample data set to calculate key performance metrics such as accuracy, precision, recall, and F1 score. These metrics are crucial as they provide a comprehensive view of how well our model is performing. For instance, accuracy gives us a general idea of the model's correctness, but precision and recall help us understand its performance in more detail, especially in distinguishing between pneumonia and non-pneumonia cases. The F1 score, on the other hand, offers a balance between precision and recall, which is particularly important in medical diagnostics, where both false positives and false negatives can have significant consequences. By the end of this exercise, you'll gain a deeper appreciation for the importance of evaluation in AI model development. Let's start by loading the dataset and examining its structure to ensure we have a solid foundation for our analysis. Let's start by importing the necessary libraries that will help us evaluate our model's performance. We are using the accuracy score, precision score, recall score, and F1 score functions from the sklearn.metrics library. These functions will allow us to calculate the key metrics we discussed earlier. Additionally, we import NumPy as it provides support for large, multi-dimensional arrays and matrices, which is useful for handling our dataset. Next, we define our sample dataset. Here, true labels represents the actual labels of the data, where 1 indicates pneumonia and 0 indicates non-pneumonia. Similarly, predicted labels represents the labels predicted by our model. Now let's calculate the accuracy of our model. The accuracy metric gives us a general idea of how often the model is correct. We use the accuracy score function, passing in our true and predicted labels. When you execute this line, you'll see the accuracy of the model printed out. Moving on to precision. This metric tells us how many of the predicted pneumonia cases were actually pneumonia. We calculate it using the precision score function. Again, execute this line to see the precision of the model. Next, we calculate recall, which indicates how many of the actual pneumonia cases were correctly identified by the model. This is done using the recall score function. Execute this line to see the recall value. Finally, we calculate the F1 score, which is the harmonic mean of precision and recall. This score is particularly useful in medical diagnostics. We use the F1 score function for this calculation. Execute this line to see the F1 score. Now let's discuss some code optimization suggestions. First, using NumPy arrays is efficient for large datasets. Second, we can modularize the code by creating functions for each metric calculation. Third, adding error handling can help manage potential issues with input data. Let's see an example of modularization and error handling. We define a function, calculate metrics, that takes true and predicted labels as input and returns all the metrics. Inside the function, we use a try-except block to catch any exceptions that might occur during the calculation. Finally, we call this function and print the results for all metrics. Execute this part to see all the metrics calculated together. By completing this exercise, you've learned how to evaluate a model using key metrics and how to optimize the code for better performance and reliability. AI has become a transformative force in the field of pneumonia detection, offering numerous real-world applications that are reshaping how we approach this critical healthcare challenge. In hospitals, AI systems are employed to analyze chest X-rays, providing quick and accurate diagnoses that can significantly improve patient outcomes. Imagine a scenario where a radiologist is overwhelmed with a backlog of X-rays to review. AI can step in to assist by rapidly processing these images, highlighting areas of concern, and allowing the radiologist to focus on the most critical cases. Beyond the hospital setting, AI is making waves in telemedicine. It enables remote diagnosis and monitoring, which is particularly beneficial in areas with limited access to healthcare facilities. For instance, a patient in a rural area can have their chest X-ray analyzed by an AI system, with the results sent to a specialist in a city, ensuring timely and effective care. These applications not only improve access to healthcare, but also reduce the burden on medical professionals, allowing them to allocate their time and expertise more efficiently. Now let's ponder a thought-provoking question. How do you think AI can further enhance pneumonia detection in the future? Could it be through more advanced algorithms, integration with wearable technology, or perhaps even real-time monitoring systems? The possibilities are vast and exciting, and they hold the promise of even greater advancements in healthcare. In this case study, we delve into a remarkable example of how AI has been successfully implemented in the field of pneumonia detection. A healthcare provider took a significant step by integrating AI into their diagnostic process, which led to faster and more accurate diagnoses. This success was largely due to the use of high-quality data and robust AI models. The implementation not only enhanced the speed and accuracy of diagnoses, but also improved patient satisfaction and reduced costs. Imagine a scenario where a patient walks into a clinic with symptoms of pneumonia. Traditionally, the diagnostic process could be time-consuming, involving multiple tests and waiting periods. However, with AI, the process becomes streamlined. The AI system quickly analyzes chest X-rays, providing immediate feedback to the healthcare provider. This not only speeds up the diagnosis, but also allows for timely treatment, which is crucial in managing pneumonia effectively. The lessons learned from this successful implementation are invaluable. They highlight the importance of high-quality data and the need for robust AI models in achieving accurate results. Additionally, the case study underscores the potential of AI to enhance patient experiences and reduce healthcare costs. As we reflect on this success, we should consider how these insights can be applied to other areas of healthcare to drive similar improvements. AI-based pneumonia detection faces several challenges that are critical to address for successful deployment. First, let's talk about data quality issues. In healthcare, data is often messy, incomplete, or inconsistent, which can significantly affect the performance of AI models. Imagine trying to build a puzzle with missing pieces. That's what poor data quality does to AI. Next, we have model biases. These biases can arise from unbalanced data sets where certain demographics are underrepresented, leading to skewed predictions. For instance, if a model is trained mostly on data from one ethnic group, it might not perform well on others. Then, there's the need for large data sets. AI models thrive on data, and without enough of it, they can't learn effectively. It's like trying to learn a new language with only a handful of words. Finally, integrating AI into existing healthcare systems can be quite complex. Healthcare systems are often rigid and not designed to accommodate new technologies easily. This integration requires careful planning and collaboration between AI experts and healthcare professionals. Addressing these challenges is crucial for the successful deployment of AI technologies. So, what strategies can we employ to overcome these challenges? Think about improving data collection methods, ensuring diverse and representative data sets, and fostering collaboration between AI developers and healthcare providers. These strategies can pave the way for more effective AI solutions in healthcare. In the realm of AI-driven pneumonia detection, overcoming limitations in AI models is crucial for enhancing diagnostic accuracy and reliability. Let's delve into some effective techniques that can significantly improve model performance. First, data augmentation is a powerful method. By artificially expanding the dataset through transformations like rotation, scaling, and flipping, we can help the model generalize better and become more robust against variations in input data. Next, transfer learning is another impactful approach. It involves leveraging pre-trained models on large datasets and fine-tuning them for pneumonia detection. This not only saves time and computational resources, but also enhances the model's ability to recognize patterns specific to pneumonia. Model ensembling is yet another technique that can boost performance. By combining predictions from multiple models, we can reduce errors and improve overall accuracy. Think of it as a team effort, where each model contributes its strengths to achieve a better outcome. Lastly, continuously updating models with new data is vital. As new patient data becomes available, retraining the models ensures they remain accurate and relevant. This ongoing process helps in adapting to new trends and variations in pneumonia cases. So, how do you think these techniques can be applied to address the limitations of AI models? Consider the potential improvements in accuracy and reliability that these methods can bring to pneumonia detection. Exploring future trends in AI for pneumonia detection reveals exciting possibilities. As we look ahead, advances in deep learning, particularly through generative adversarial networks, or GANs, are offering innovative ways to enhance diagnostic accuracy. GANs can generate synthetic data that closely resembles real-world data, which can be used to train models more effectively, especially when actual data is scarce. Another promising trend is the integration of AI with wearable devices. Imagine a world where your smartwatch or fitness tracker continuously monitors your respiratory health, alerting you and your healthcare provider at the first sign of pneumonia. This continuous monitoring can lead to earlier detection and intervention, significantly improving patient outcomes. These trends are not just about technology. They promise to enhance patient care and outcomes by making healthcare more proactive and personalized. Now think about this. What future trends do you believe will have the most impact on pneumonia detection? As we ponder this question, consider how these advancements could transform the landscape of healthcare, making it more efficient and effective for everyone involved. Innovations in AI are paving the way for future directions in pneumonia detection. Emerging technologies such as quantum computing hold the potential to revolutionize AI capabilities. Imagine a world where quantum computing accelerates the processing power of AI, enabling it to analyze vast datasets in seconds. This could lead to more accurate and faster pneumonia diagnoses, ultimately saving lives. Collaboration between AI researchers and healthcare professionals is also crucial for driving innovation. By working together, they can ensure that AI tools are not only technically advanced, but also clinically relevant and user-friendly. This partnership is essential for creating solutions that truly meet the needs of healthcare providers and patients. These developments will shape the future of pneumonia detection and treatment. As AI continues to evolve, it will likely become an integral part of healthcare, offering new ways to diagnose, monitor, and treat diseases. How do you envision the future of AI in healthcare? Consider the possibilities and the impact it could have on improving patient outcomes and transforming the healthcare landscape. Welcome to our discussion on AI in remote patient monitoring. Remote patient monitoring, or RPM, is a transformative method of healthcare delivery that leverages technology to keep an eye on patients outside of traditional clinical settings, such as in their homes. AI plays a pivotal role in RPM by analyzing data collected from patients in real time. This capability allows healthcare providers to make informed decisions swiftly, which is particularly crucial for patients with chronic conditions who need continuous monitoring. By harnessing the power of AI, RPM systems can detect anomalies, predict potential health issues, and alert healthcare providers promptly. This proactive approach not only improves patient outcomes, but also significantly reduces hospital readmissions. Imagine a scenario where a patient with a heart condition is being monitored at home. The AI system can detect irregular heartbeats and alert the healthcare provider before it escalates into a serious issue. Can you think of any other examples where remote monitoring could be beneficial in healthcare? Building on our understanding of remote patient monitoring, let's delve into the transformative benefits of AI in remote healthcare. AI significantly enhances remote healthcare by offering personalized care tailored to individual patient needs. This personalization improves patient engagement as patients feel more connected and involved in their healthcare journey. Moreover, AI contributes to reducing healthcare costs by streamlining processes and optimizing resource allocation. One of the standout advantages of AI is its ability to enable continuous monitoring and early detection of health issues. This capability allows for timely interventions, potentially preventing complications and improving patient outcomes. AI algorithms excel at analyzing vast amounts of data, identifying patterns and trends that might be overlooked by human observers. This leads to more accurate diagnoses and more effective treatment plans, enhancing the overall quality of care. Additionally, AI can automate routine tasks, such as data entry and scheduling, freeing up healthcare professionals to focus on more complex and critical aspects of patient care. Now consider how these benefits could impact patient satisfaction and the overall delivery of healthcare. With AI support, patients receive more attentive and efficient care, which can lead to higher satisfaction levels. Healthcare delivery becomes more proactive and less reactive, ultimately fostering a more sustainable healthcare system. Building on our understanding of AI's role in remote healthcare, let's delve into the exciting world of integrating AI with wearable technology. Wearable devices like smartwatches and fitness trackers are not just trendy gadgets. They are powerful tools that collect a vast array of health-related data. By integrating AI, these devices can transform raw data into real-time insights and personalized health recommendations. Imagine your smartwatch not only tracking your steps, but also analyzing your heart rate to detect irregular rhythms, or your fitness tracker providing tailored advice based on your activity levels and sleep patterns. AI algorithms process the data from these wearables to monitor vital signs, track physical activity, and even detect anomalies like irregular heart rhythms. This integration empowers users to take proactive steps in managing their health, offering them a more personalized healthcare experience. Moreover, it provides healthcare providers with valuable data, enabling them to make informed decisions and offer better patient care. So, think about the wearable devices you use. How do you believe AI could enhance their functionality and impact your health management? In this case study, we explore the fascinating world of AI-enhanced wearables, focusing on a company that has developed a smartwatch with the capability to detect atrial fibrillation, a common heart rhythm disorder. This smartwatch uses advanced AI algorithms to analyze heart rate data, identifying irregular patterns that could indicate a problem. When such patterns are detected, the watch promptly alerts the user and offers the option to share this critical data with their healthcare provider. This early detection is crucial as it can prevent serious complications, such as stroke, by enabling timely medical intervention. This case study beautifully illustrates the potential of AI-enhanced wearables in delivering timely and actionable health insights. Now, think about other health conditions that could benefit from similar AI-enhanced wearable technology. Conditions like sleep apnea, diabetes, or even mental health monitoring could be revolutionized by these smart devices. The possibilities are vast, and the impact on personal health management could be profound. In our journey through AI in healthcare, let's now explore the transformative role of AI in chronic disease management. Chronic diseases, such as diabetes and hypertension, are long-term conditions that require continuous monitoring and management. These conditions can be quite challenging for both patients and healthcare providers due to their persistent nature. AI steps in as a powerful ally by analyzing vast amounts of patient data to predict disease progression and recommend personalized treatment plans. For instance, in diabetes management, AI can analyze glucose levels and suggest precise insulin dosages, helping patients maintain optimal blood sugar levels. Moreover, AI can identify lifestyle changes that could significantly improve patient outcomes, such as dietary adjustments or exercise routines. By providing continuous support and actionable insights, AI empowers patients to take control of their health, making them active participants in their care journey. This not only enhances patient autonomy, but also reduces the burden on healthcare systems by potentially decreasing the frequency of hospital visits and interventions. So, how do you think AI could revolutionize the management of chronic diseases? Consider the possibilities and the profound impact it could have on patient lives and healthcare efficiency. In the realm of chronic care, AI is making significant strides with real-world applications that are transforming patient management. Take heart failure, for instance. AI algorithms are now capable of analyzing data from implantable devices, such as pacemakers, to monitor heart function continuously. This technology can detect early signs of deterioration, allowing healthcare providers to intervene promptly and potentially prevent hospitalizations. Another compelling application is in diabetes management. AI-powered applications can provide personalized recommendations by analyzing blood sugar levels and lifestyle data. This means that patients receive tailored advice on diet, exercise, and medication, which can significantly improve their quality of life and health outcomes. These examples highlight the profound impact AI can have on chronic care, enhancing patient outcomes and quality of life. Now, think about other chronic conditions, such as asthma or chronic obstructive pulmonary disease. How might AI applications be leveraged to benefit these conditions? The possibilities are vast, and as AI technology continues to evolve, its role in chronic care will only expand, offering new ways to manage and improve patient health. In the fast-paced world of healthcare, real-time data analysis using AI is a game changer. It's crucial for monitoring patient conditions and making timely decisions that can significantly impact patient outcomes. AI algorithms have the remarkable ability to process and analyze data from various sources, such as wearables and medical devices, in real time. This capability allows healthcare providers to detect anomalies, predict potential health issues, and respond swiftly. Imagine a scenario where AI analyzes ECG data to detect arrhythmias as they occur. This immediate analysis enables healthcare professionals to intervene proactively, potentially preventing serious complications. Real-time analysis not only improves patient outcomes by enabling proactive care, but also reduces response times, which is vital in emergency situations. Now, think about how this could revolutionize emergency care. In emergencies, every second counts. Real-time data analysis can provide critical insights that guide immediate medical interventions, potentially saving lives. So, how do you think real-time data analysis could impact emergency care? In our journey through AI in healthcare, we've seen how real-time data analysis can revolutionize patient care. Now, let's delve into the challenges that come with implementing real-time AI applications. One of the primary hurdles is the need for high-quality, continuous data streams. Imagine trying to watch a movie with a poor internet connection. The experience is frustrating and incomplete. Similarly, maintaining a steady flow of accurate data is crucial for AI systems to function effectively. Another significant challenge is data privacy and security. Real-time applications often handle sensitive patient information, and any breach could have serious implications. It's like having a vault of personal secrets that needs to be guarded at all times. Integrating AI systems with existing healthcare infrastructure is another complex task. It can be likened to fitting a new engine into an old car. It requires precision and can be costly. Moreover, the accuracy and reliability of AI algorithms are paramount. Errors in AI predictions or analyses can lead to severe consequences, much like a misdiagnosis in a medical setting. Addressing these challenges isn't a solo endeavor. It requires a collaborative effort between technology developers, healthcare providers, and regulatory bodies. Each plays a vital role in ensuring that AI applications are safe, effective, and beneficial to patient care. So, what other challenges do you think might arise in real-time AI applications? Consider the complexities and think about how they might be addressed. Now, let's delve into the fascinating world of predictive health monitoring with AI. This innovative approach leverages artificial intelligence to analyze patient data and forecast potential health events before they occur. Imagine being able to foresee a health issue and take action before it becomes a problem. That's the power of predictive health monitoring. By examining a patient's health data and lifestyle factors, AI can predict the likelihood of developing chronic conditions, such as diabetes or heart disease. This foresight allows healthcare providers to craft personalized care plans and implement preventative measures, ultimately improving patient outcomes. For instance, if AI predicts a high risk of diabetes in a patient, healthcare providers can intervene early with lifestyle changes and monitoring, potentially preventing the onset of the disease. Moreover, predictive monitoring is instrumental in identifying patients at risk of hospital readmissions. By pinpointing these individuals, healthcare providers can offer targeted interventions, reducing the likelihood of readmission and enhancing the patient's quality of life. So, how might predictive health monitoring revolutionize healthcare delivery? It could shift the focus from reactive to proactive care, where the emphasis is on prevention rather than treatment. This not only improves patient health, but also reduces healthcare costs. What are your thoughts on how predictive health monitoring could transform the healthcare landscape? As we wrap up our exploration of predictive monitoring, let's delve into the exciting future directions this technology is heading towards. With the rapid advancement of AI, predictive monitoring is set to become even more accurate and personalized. Imagine a world where AI systems can not only predict health events with remarkable precision, but also offer real-time recommendations tailored to each individual. The integration of AI with other cutting-edge technologies, such as the Internet of Things and big data analytics, will significantly enhance its capabilities. This synergy will allow for more comprehensive data collection and analysis, leading to better informed healthcare decisions. Furthermore, as we continue to make strides in data privacy and security, these advancements will address current challenges and pave the way for wider adoption of predictive monitoring systems. The future of predictive monitoring holds immense potential for improving patient outcomes and revolutionizing healthcare delivery. It's an exciting time to be part of this transformation. So, what future developments do you envision in predictive monitoring? How do you see these advancements shaping the healthcare landscape? Welcome to our discussion on AI and personalized treatment planning. Personalized treatment planning is a revolutionary approach in healthcare that tailors medical treatment to the individual characteristics of each patient. AI plays a crucial role in this by analyzing vast amounts of data, including genetic information, lifestyle, and medical history, to recommend the most effective treatment plans. This approach not only improves patient outcomes, but also enhances the efficiency of healthcare delivery. Imagine a world where treatments are as unique as the patients themselves, leading to faster recoveries and fewer side effects. As we delve deeper, consider how AI's ability to process and analyze data at an unprecedented scale is transforming the way we approach treatment planning. By leveraging AI, healthcare providers can make more informed decisions, ensuring that each patient receives the best possible care tailored specifically to their needs. Building on our discussion of personalized treatment planning, let's now explore the significant benefits AI brings to personalized medicine. AI enhances personalized medicine by offering more accurate diagnoses, predicting disease progression, and identifying the best treatment options tailored to individual patients. This precision leads to improved patient outcomes, reduced healthcare costs, and a more efficient use of resources. For example, AI can analyze patient data to determine which individuals are most likely to respond positively to a specific drug, thereby avoiding unnecessary treatments and minimizing potential side effects. As we consider these benefits, it's important to view AI not just as a tool, but as a partner in healthcare. It enables more precise and effective medical care, transforming the way we approach patient treatment. Think about how this partnership between AI and healthcare professionals can lead to a future where medical care is not only more effective, but also more personalized, ensuring that each patient receives the best possible care tailored to their unique needs. Now, let's explore the pivotal role of machine learning in the realm of drug discovery. Drug discovery is traditionally a complex and expensive endeavor, often requiring years and billions of dollars to bring a new drug to market. However, machine learning is revolutionizing this process by enabling the analysis of vast data sets to identify potential drug candidates, predict their efficacy, and optimize their chemical structures. This not only accelerates the discovery process, but also significantly reduces costs and increases the likelihood of success. Imagine machine learning algorithms sifting through enormous amounts of biological data, uncovering hidden patterns and insights that would be impossible for humans to detect. As we delve deeper, consider the transformative impact of machine learning on the pharmaceutical industry. It's not just about speeding up processes, it's about enhancing precision and innovation in drug discovery. Machine learning allows researchers to focus on the most promising drug candidates, reducing the time and resources spent on less viable options. This efficiency is crucial in a field where time is of the essence, especially when addressing urgent health crises. So, as we proceed, think about how machine learning is not just a tool, but a game changer in the pharmaceutical industry, paving the way for more effective and efficient drug discovery. All right, let's now dive into a hands-on exercise to put today's ideas into practice. In this code example, we're going to simulate a simple machine learning process in drug discovery using a synthetic dataset. First, we import the necessary libraries. We use NumPy for data handling, and from scikit-learn, we import tools for splitting data, building a model, and evaluating its performance. Next, we generate a synthetic dataset. Imagine this dataset as a collection of chemical properties of various compounds. Each compound is represented by a set of features, and we have a target variable indicating whether a compound is effective as a drug or not. We set a random seed for reproducibility, ensuring that our results can be replicated. We define the number of samples and features, which represent the number of compounds and their chemical properties, respectively. We then randomly generate feature data using NumPy. This data simulates the chemical properties of the compounds for the target data. We randomly assign values to indicate efficacy, with 1 representing effective and 0 representing ineffective. We assume that 30% of the samples are effective. Now we split our dataset into training and testing sets. This is crucial for evaluating the model's performance on unseen data. We initialize a random forest classifier, a popular machine learning model known for its robustness and accuracy. We train the model using the training data. This step involves the model learning patterns from the data to make predictions. After training, we use the model to predict the efficacy of the test data. Finally, we calculate the accuracy of the model by comparing the predicted values with the actual test data. The accuracy score gives us an idea of how well our model is performing. Execute the print statement to see the model's accuracy. In summary, we've walked through a basic machine learning workflow in drug discovery, from data generation to model evaluation. This exercise highlights how machine learning can streamline the drug discovery process by efficiently analyzing chemical data. Feel free to experiment with the code, perhaps by changing the number of samples or features to see how it affects the model. As performance, this hands-on experience reinforces the transformative role of machine learning in the pharmaceutical industry. As we discussed earlier, keep exploring and experimenting, and you'll continue to uncover the potential of machine learning and drug discovery. In this case study, we will delve into the fascinating application of machine learning in the realm of drug development. One particularly noteworthy example is how pharmaceutical companies are leveraging machine learning to predict the success of drug compounds during clinical trials. By meticulously analyzing historical trial data, machine learning models can pinpoint the factors that contribute to the success or failure of these trials. This empowers researchers to make more informed and strategic decisions. The impact of this is profound. It not only enhances the efficiency of the drug development process, but also significantly reduces the risk of costly failures. Imagine the traditional approach as navigating a maze blindfolded, while machine learning provides a map that highlights the most promising paths. As we explore this case study, consider how machine learning is reshaping the landscape of drug development. It's making the process more data-driven and predictive, allowing for a more streamlined and successful journey from concept to market. Think about the potential of these technologies to revolutionize the pharmaceutical industry, making it more agile and responsive to the needs of patients worldwide. Now, let's discuss AI techniques for drug repurposing. Drug repurposing involves finding new uses for existing drugs, which can be a faster and more cost-effective way to bring treatments to market. AI techniques such as machine learning and deep learning are used to analyze biological and chemical data to identify potential new applications for existing drugs. This approach not only saves time and resources, but also leverages the safety profiles of already approved drugs. As we delve into these techniques, think about how AI is opening new avenues for innovation in drug development by uncovering hidden potential in existing medications. Imagine a world where a drug initially developed for one disease could be quickly adapted to treat another, all thanks to the power of AI. By analyzing vast data sets, AI can reveal connections and possibilities that might be missed by traditional methods. This not only accelerates the drug development process, but also enhances the potential for personalized medicine, where treatments are tailored to individual patient needs. So as we explore these AI techniques, consider the transformative impact they have on the healthcare landscape, making treatments more accessible and effective for patients worldwide. All right, let's now dive into a hands-on exercise to put today's ideas into practice. We're going to explore a simple example of using machine learning to predict potential new uses for existing drugs. Imagine we have a data set of drugs and their known effects, and we want to train a model to predict new applications. First, we import the necessary libraries. We use pandas for data manipulation, and from scikit-learn, we import tools for model training and evaluation. Next, we create a hypothetical dataset. Each row represents a drug with features that describe its chemical properties and known effects. The target column indicates the current known application of the drug. In reality, this data would be more complex and sourced from biological databases. We then convert this data into a data frame, which allows us to easily manipulate and analyze it. Now we prepare the data for training by separating the features from the target. The features, or X, are the chemical properties and known effects, while the target, or Y, is the current application. We split the data into training and testing sets to evaluate our model's performance. This is crucial for understanding how well our model generalizes to new data. We initialize a random forest classifier, a simple yet powerful machine learning model suitable for classification tasks. We then train the model on the training data. After training, we make predictions on the test data. Finally, we evaluate the model's performance by calculating its accuracy. Execute the print statement to see the model's accuracy. In a real-world application, this model could be used to predict new potential applications for drugs by analyzing their chemical properties and known effects. To optimize this code, consider using more advanced models like deep learning for complex data sets. Implementing cross-validation for robustness using feature selection techniques and incorporating error handling. By completing this exercise, you've seen how machine learning can be applied to drug repurposing, offering a glimpse into how I can transform healthcare by finding new uses for existing medications. Feel free to experiment with the code. Try different models or use real-world data sets to see how these techniques can be applied in practice. Building on our understanding of AI techniques for drug repurposing, let's delve into some inspiring success stories that showcase the transformative power of AI in this field. One of the most notable examples is the repurposing of remdesivir. Originally developed to combat Ebola, AI models identified its potential efficacy against COVID-19. This discovery was pivotal as it allowed for the rapid deployment of remdesivir in clinical settings during the pandemic, providing a much-needed treatment option when time was of the essence. Another compelling story is the repurposing of thalidomide. Once infamous for its adverse effects, AI-driven research found a new application for thalidomide in treating multiple myeloma, a type of cancer. This not only gave the drug a new lease on life, but also provided a valuable treatment option for patients battling this disease. These examples highlight the incredible potential of AI-driven drug repurposing to accelerate the availability of effective treatments for emerging health challenges. As we reflect on these stories, consider the broader impact of AI on global health. AI is not just a tool for innovation, it's a catalyst for addressing unmet medical needs and improving patient outcomes worldwide. The ability of AI to uncover new uses for existing drugs underscores its role in transforming healthcare, making it more responsive and adaptive to the challenges we face. Deep learning is making waves in the field of genomics, a branch of biology focused on the comprehensive study of an organism's DNA. This technology is transforming how we analyze complex genomic data. By leveraging deep learning models, we can identify intricate patterns and variations within genetic sequences. This capability allows us to predict disease risks and even propose personalized treatment options tailored to an individual's unique genetic makeup. The implications for precision medicine are profound. Imagine treatments specifically designed for your genetic profile, enhancing their effectiveness and reducing potential side effects. As we explore these applications, consider how deep learning is unlocking the secrets of our DNA, paving the way for a new era of personalized healthcare. This is not just a technological advancement, it's a revolution in how we understand and treat diseases, offering hope for more targeted and effective healthcare solutions. All right, let's now dive into a hands-on exercise to put today's ideas into practice. In this code example, we're going to see how deep learning can be applied to genomics data to predict disease risks based on genetic sequences. Using a simple neural network, first, we import the necessary libraries. We use NumPy for numerical operations and TensorFlow's Keras for building our neural network. Next, we simulate some genomic data. Imagine each genetic sequence as a vector of 100 features, and we have 1,000 such samples. We set a random seed for reproducibility, ensuring that our results can be replicated. We then create our feature matrix X, which represents the genetic sequences, and our label vector Y, which indicates the presence or absence of a disease. Now let's define a simple neural network model. We use Keras Sequential API to stack layers. Our model starts with an input layer of 64 neurons with a ReLU activation function, followed by a hidden layer of 32 neurons, and finally, an output layer with a single neuron, using a sigmoid activation function. For binary classification, we compile the model using the Atom Optimizer, which is efficient for training deep learning models. We use binary cross-entropy as the loss function since we're dealing with a binary classification problem, and we track accuracy as a metric. Now we train the model on our data. We set the number of epochs to 10, meaning the model will see the entire dataset 10 times. We use a batch size of 32 and reserve 20% of the data for validation, to monitor the model's performance on unseen data. After training, we simulate a new genetic sequence to predict its disease risk. We generate a random vector of 100 features and use our trained model to make a prediction. Finally, we output the predicted disease risk. The prediction is a probability value between 0 and 1, indicating the likelihood of disease presence. Remember, this is a basic model in real-world applications. You might use more complex models like convolutional neural networks for better pattern recognition, implement data augmentation to increase training data diversity, or use dropout layers to prevent overfitting. You could also consider using pre-trained models or transfer learning for more efficient training. And don't forget to implement error handling to manage unexpected data inputs or model failures. By completing this exercise, you've seen how deep learning can be applied to genomics data to predict disease risks. This hands-on experience reinforces the connection between deep learning and precision medicine, showcasing how technology can bring abstract logic into action. Feel free to tweak the code or try variations on your own to deepen your understanding. In this slide, we will delve into the challenges faced in genomic data analysis. Analyzing genomic data is no small feat, primarily due to the immense volume and intricate nature of the data involved. Imagine trying to read a book with billions of pages, each filled with complex codes. That's the scale we're dealing with here. One of the primary challenges is data storage and management. Genomic data is vast, and storing it efficiently while ensuring easy access is a significant hurdle. Then, there's the computational power required to process this data. It demands sophisticated algorithms and high-performance computing resources to interpret the data accurately. But it's not just about the technical challenges. Ethical considerations play a crucial role too. When dealing with sensitive genetic information, issues like data privacy and obtaining informed consent are paramount. We must ensure that individuals' genetic data is protected and used responsibly. As we explore these challenges, it's essential to recognize the importance of developing robust solutions. Overcoming these hurdles is crucial to harnessing the full potential of genomic data, which can lead to significant advancements in healthcare. By addressing these challenges, we can unlock new possibilities for personalized medicine and improve patient outcomes. So, as we move forward, consider how we can tackle these challenges to make the most of genomic data in healthcare. Now, let's delve into the fascinating world of AI innovations in clinical trial design. Clinical trials are a cornerstone of medical research, crucial for assessing the safety and effectiveness of new treatments. However, they are often plagued by lengthy timelines and high costs. This is where AI steps in as a game changer. By optimizing patient selection, predicting trial outcomes, and identifying potential risks, AI is revolutionizing the way trials are conducted. Imagine being able to sift through vast amounts of patient data to pinpoint individuals who are most likely to benefit from a new treatment. This not only enhances the trial's success rate, but also ensures that the right patients receive the right therapies. AI's ability to predict trial outcomes and identify risks early on means that trials can be more efficient, yielding faster results and significantly reducing costs. As we explore these innovations, consider how AI is not just streamlining the clinical trial process, but also accelerating the development of new therapies, ultimately bringing hope and healing to patients more swiftly. As we wrap up our exploration of AI in clinical trials, let's delve into the exciting future that lies ahead. With the continuous evolution of AI, its role in clinical trials is set to expand significantly. Imagine a world where clinical trials are not only more personalized, but also adaptive to the needs of each participant. This is the promise of AI. Future advancements in AI could lead to real-time monitoring of trial participants, allowing researchers to gather data instantaneously and make informed decisions on the fly. This means that adjustments to the trial can be made in real time, enhancing the safety and efficacy of the process. Predictive analytics powered by AI will enable researchers to forecast trial outcomes with greater accuracy. This could drastically reduce the time it takes to bring new treatments to market, as potential issues can be identified and addressed early on. Moreover, the integration of AI with other cutting-edge technologies, such as wearable devices and telemedicine, is set to revolutionize the way clinical trials are conducted. Wearable devices can provide continuous health data, while telemedicine can facilitate remote participation, making trials more accessible and patient-centric. These innovations hold the potential to make clinical trials more efficient, cost-effective, and ultimately more successful. As we conclude, I encourage you to reflect on the transformative impact AI will have on the future of clinical trials. It's an exciting time as AI paves the way for faster, more effective treatments, bringing hope to patients around the world. Welcome to our discussion on ethical considerations in generative AI. As we delve into this topic, it's crucial to understand that generative AI, while powerful, raises significant ethical questions. These include concerns about privacy, consent, and the potential misuse of AI-generated content. For instance, AI can create realistic images or text that could be used to deceive or manipulate. This raises questions about authenticity and trust. Additionally, there's the issue of accountability. If an AI system generates harmful content, who is responsible? Is it the developer, the user, or the AI itself? These are complex questions without straightforward answers, but they are essential to consider as we advance in AI technology. Let's explore these issues further and discuss how they impact the development and deployment of generative AI systems. As we continue our exploration into generative AI, it's essential to understand the potential risks that accompany this powerful technology. One of the most pressing concerns is the creation of deepfakes. These are AI-generated videos or images that can be incredibly realistic and are often used to spread misinformation. Imagine a scenario where a deepfake video is released during an election campaign, showing a candidate saying something they never actually said. This could severely undermine public trust and have serious implications in politics and media. Another significant risk is the potential for AI to perpetuate or even amplify existing biases. If the data used to train AI models is biased, the AI's outputs will likely reflect those biases. This can lead to unfair treatment or discrimination, particularly in sensitive areas like hiring or law enforcement. For example, if an AI system is trained on data that underrepresents certain groups, it might make biased decisions that disadvantage those groups. Additionally, there's the risk of over-reliance on AI systems. As we become more dependent on AI, there's a danger that we might lose essential human skills and judgment. Consider a scenario where healthcare professionals rely too heavily on AI for diagnoses, potentially overlooking critical nuances that a human might catch. As we advance in developing and deploying generative AI, it's crucial to remain vigilant about these risks and actively work towards mitigating them. By doing so, we can harness the benefits of AI while minimizing its potential downsides. Addressing bias in generative AI is indeed a critical challenge, and it requires a comprehensive and multifaceted approach. Let's start by considering the data used to train AI models. Ensuring diversity in this data is crucial by incorporating a wide range of perspectives and experiences. We can significantly reduce the risk of bias. Imagine a dataset that only includes data from a single demographic. The AI trained on this data would likely reflect the biases inherent in that limited perspective. Now, another effective strategy is the implementation of fairness-aware algorithms. These algorithms are specifically designed to detect and mitigate bias during the training process. They act like a filter, identifying potential biases and adjusting the model to ensure fairness. Regular audits and evaluations of AI systems are also essential. Just like a car needs regular maintenance to run smoothly, AI systems require ongoing checks to identify and address any biases that may emerge over time. Furthermore, involving diverse teams in the development of AI systems is vital. A team with varied backgrounds can provide valuable insights and help ensure that the AI is fair and equitable. This diversity in thought and experience can lead to more inclusive and just AI systems. By taking these steps, we can work towards creating generative AI systems that are not only more inclusive, but also more just, ultimately benefiting society as a whole. As we look to the future of generative AI, several exciting trends are emerging. One of the most promising developments is the creation of more advanced and efficient AI models. These models are designed to generate high-quality content while using less computational power. Imagine being able to produce complex AI-driven content without needing a supercomputer. This advancement could democratize access to generative AI, making it more accessible and widely used across various industries, from healthcare to entertainment. Another fascinating trend is the integration of generative AI with other cutting-edge technologies, such as augmented reality and virtual reality. This combination can lead to the creation of immersive and interactive experiences that were once the stuff of science fiction. Picture a virtual reality environment that adapts in real time to your preferences, creating a personalized experience just for you. Speaking of personalization, we can also expect to see more AI systems that tailor their outputs to individual preferences and needs. This means AI could become a personal assistant that truly understands and anticipates your needs, enhancing productivity and user satisfaction. However, with these advancements come new challenges, particularly in terms of ethics and regulation. As we continue to innovate, it's crucial to consider the implications of these technologies. We must work towards responsible and ethical AI development to ensure that these powerful tools are used for the benefit of all, without compromising privacy or fairness. By staying informed and proactive, we can navigate these challenges and harness the full potential of generative AI for a better future. In this slide, we're going to explore some best practices for ensuring the ethical use of AI. Let's start with transparency. It's absolutely essential that AI systems are designed to be understandable and explainable. This means users should have a clear understanding of how decisions are made by these systems. Imagine using a navigation app that doesn't tell you why it's choosing a particular route. You'd want to know the reasoning behind it, right? Similarly, AI systems should be transparent in their decision-making processes. Next, we must prioritize privacy and data protection. Personal information should be handled with the utmost care and responsibility. Think of it like safeguarding a treasure chest of sensitive data. Regular updates and audits of AI systems are crucial. They help identify and address any ethical concerns that might arise over time. Involving diverse stakeholders in the development process is another key practice. By bringing in a variety of perspectives, we can ensure that the AI is fair and equitable. It's like having a diverse team of chefs creating a dish that appeals to a wide range of tastes. Finally, fostering a culture of accountability is vital. Organizations should be ready to take responsibility for the actions of their AI systems and strive for continuous improvement. It's about being prepared to own up to mistakes and learn from them. By following these guidelines, we can work towards creating AI systems that are not only ethical, but also trustworthy. This is crucial as we continue to integrate AI into various aspects of our lives. Navigating the regulatory landscape of generative AI is indeed a complex task. This complexity arises because the technology is evolving at a rapid pace, and existing regulations may not fully address the unique challenges it presents. One of the primary challenges is the absence of standardized guidelines for AI development and deployment. This lack of standardization can lead to inconsistencies and confusion among developers, users, and regulators alike. Another significant issue is the matter of cross-border regulations. AI systems often operate on a global scale, which means they must comply with a variety of legal frameworks from different countries. This can create a tangled web of compliance requirements that are difficult to navigate. To effectively address these challenges, it's crucial for policymakers to collaborate closely with AI developers and other stakeholders. This collaboration can help in crafting comprehensive and flexible regulations that are capable of adapting to the ever-changing landscape of AI technology. Such regulations should include clear guidelines for data privacy, ensuring that personal information is protected. They should also establish accountability measures so that there is a clear understanding of who is responsible for the actions of AI systems. Transparency is another key element, as it allows users to understand how AI decisions are made. By taking a proactive approach to regulation, we can help ensure that generative AI is developed and used in a manner that is safe, ethical, and beneficial for society. This proactive stance not only safeguards users, but also fosters trust in AI technologies, paving the way for their responsible and innovative use in the future. Let's bring it all together. In this video, you saw AI show up across the entire healthcare journey. Generative AI and LLMs, the foundation now powering clinical tools and decision support. Health management systems, AI reducing administrative load and improving hospital efficiency. Diagnosis, AI reading scans and flagging conditions earlier and faster. Pneumonia detection case study, a real hands-on look at how a model is trained on medical imaging from raw data to a working diagnostic tool. Patient monitoring and wearables, AI enabling continuous real-time care beyond the hospital. Treatment and drug discovery, AI personalizing treatment plans and accelerating how new medicines are found. Risks, ethics, and the future. The limitations, biases, and responsibilities that come with all of the above. If this gave you a clearer picture of where healthcare is heading, that's just the beginning. This video is based on Great Learning's AI in Healthcare course, which is free to start and a great first step if you want to go deeper into GenAI, diagnosis, treatment planning, drug discovery, and responsible AI in this space. And if you're ready to go from understanding AI in healthcare to actually applying it, Great Learning also offers advanced pathways depending on where you want to take this. If you want applied, hands-on skills in clinical decision support and predictive analytics, check out the AI in Healthcare Certificate Program with Johns Hopkins University. And if you want to build core AI and machine learning skills that apply across healthcare and every other industry, check out Great Learning's PG program in Artificial Intelligence and Machine Learning. Links to all of these are in the description. Head to mygreatlearning.com to explore the full catalog. If you found this useful, hit like, subscribe for more breakdowns like this, and drop a comment. Would you trust an AI to help diagnose you? I want to know. Thanks for watching. See you in the next one.